here is our third and fourth examples. Of using molarity as a conversion factor. Okay, how many moles of potassium bromide would you need to make 250 milliliters of a 0.150 molar KBr solution? Now, I don't know if you remember from our previous video, but the first thing you need to do is you need to rewrite molarity, capital M, as moles per liter. And so we're going to do that right here. 0.150 instead of molar, we're going to rewrite it as moles per liter, and that gives us a lovely conversion factor. The second thing that we need to do is, if we are given milliliters, we need to rewrite in liters instead, so that we can use our moles per liter conversion factor. So 250 milliliters is equal to, move our decimal place 1, 2, 3 spaces, 0.250 liters. Okay, and that is going to be our initial quantity. And our unknown, look for your question words, how many moles? Okay, so our unknown is how many moles of KBr. Ooh, everything's jumping around. That's exciting. Okay, so solving this, our unknown is equal to our initial times our conversion factor. And we get our unknown, how many moles of KBr, is equal to our initial, which is 0.250 liters, times our conversion factor. Now we need to cancel liters and find moles, so we can take our moles per liter and use it just as is. That's 0.150 moles per liter. We do that and we get 0.0375. But, oh, I made a boo-boo. Look at this. We had 250 milliliters. That right there, my friends, how many sig figs? Only 2 sig figs. So when I rewrote it here, I should not have written that 0. That should go away. So that should not be there, which would mean that our final overall answer should be to 2 sig figs, 0.038, and the liters cancel, so all we're left with is moles, and that's moles of KBr. Second example, going the other way from moles to liters. How many milliliters of 3.0 molar NaOH can be prepared from 0.15 moles of NaOH? All right, if we're going to do this, remember the first thing we're going to do is we're going to rewrite molarity, M, capital M, as moles per liter. And so that is 3.0 moles per liter. Moles of NaOH per liter. There is a conversion factor, 1 unit over another unit. Second thing we would do is we would write milliliters as liters if it's given in the question, but it's not, so we don't have to do that. Unnecessary here. All right, so what is our initial quantity? Well, it's the only other thing given in the question. That's 0.15 moles of NaOH. And our unknown, look for those question words, how many milliliters? How many milliliters? All right, so our unknown is equal to our initial quantity times the conversion factor. So our unknown, which is we don't know how many milliliters, is equal to our initial quantity, 0.15 moles, times our conversion factor. We need to cancel moles. Now, wouldn't it be nice if we could find milliliters? But we don't know the conversion factor between moles and milliliters. I'm sure some of you could do it in your head, but don't worry about it. We don't really need to, but we can change moles into liters. And don't forget that means we're turning this upside down, so the 3.0 goes on the bottom and the 1 liter goes on the top. And then we are going to do our second step, which would be converting liters into milliliters, and there are 1,000 milliliters in 1 liter. So 0.15 divided by 3 times 1,000 gives us 50 milliliters. 2 sig figs here, 2 sig figs here, and infinite sig figs here, and here, and here. And so we need to have 2 sig figs in our answer. How many sig figs in the answer as it is right now? As it is right now, there's only 1 sig fig in the answer, so we have to do we have one of several options. One way you can do it is you can say 5, 0, 50, and then just put a decimal after it, milliliters, and that is okay. It's a little weird, but it's all right. Second way to do it, you can write it as in scientific notation. Change it to 5.0, that gives us 2 sig figs, and then because we made the 50 smaller and it became 5, we have to have a power of 10 here. And one thing to note when you're doing scientific notation, it's not just okay to write 5.0 times 10. You have to have an exponent on that 10, and in this case that exponent would be a 1. Okay? Or finally, there is a third way to deal with, and that is to write 50 with an over bar. Okay, that right there is an over bar. And the over bar indicates the last sig fig. And it's not, this is unusual. And so although you can use it in my class, I would recommend that if you are doing this for AP, you choose one of these two. Okay? And don't forget your unit in any event, whichever method you choose. Thank you very much, and